Welcome back to lesson 6.2. So in 6.1, you extended your learning regarding the empirical rule to what we're going to call the normal curve and calculated some z-scores and reminding yourself that z-scores are the average number of standard deviations. Right here I have it again. We know that a z-score is the average number of standard deviations and observation is above or below the mean. And we also know the z can be described as a normally distributed with a mean of 0 and a standard deviation of 1. So we are going to put that together with being able to find areas under a curve that aren't actually at the exact standard deviations that we use with a z-score. And the empirical rule, because the empirical rule was only particular standard deviations, 1, 2, 3 above, 1, 2, 3 below the mean. But now we want to find it for any value. So we have to remind ourselves that just like we said, the entire probability under a curve using the empirical rule was 1. The shaded area in the following graph indicates the area to the left of x. So the area under the entire curve is 1. So the area left of x is going to be the probability of x being less than x. And the area to the right is going to be the probability of the area greater than x. So the area to the right is then the complement of the area to the left. Okay. So remember that the probability of x being less than x is area to the left of the vertical line through x. Okay. So we're going to first look at probabilities of a normal curve using the z-score, where the mean is 0 and the standard deviation is 1 for a z. So we're going to be calculating some critical z values, and we're going to use these critical z values for the rest of the semester because if we recall back earlier in chapters 2 and 4, it was chapter 2, we said that an observation was considered unusual if it fell below 2 standard deviations below the mean or 2 standard deviations above the mean. And that is basically a z value of 2 or -2. And so now we want to look at other critical values because we're not going to always use the rule of plus or minus 2. Depending on the situation, we might be using a different critical value because we have other reasons for being more stringent or less stringent. Okay, so we're going to focus on just learning how to calculate critical z values in this lesson. So a critical z value is denoted with this little a for alpha. So this is the Greek letter alpha. It's a z-score with an area to its right. So alpha is always area to the right. And note, a negative z of alpha will be a z-score with an area to the left. So in Desmos, to find this area, we are going to use the normal distribution, but it's going to be 0 and 1 for the z-score. Also remind yourself that we have to click the box for the find the cumulative probability. So let's look at a few examples. It says, if we know that a distribution is normally distributed, what is the probability that a value will be more than 1 standard deviation below the mean? So I am going to draw it like this. And I am going to put, this is the probability of z being less than a -1. And z is normally distributed. Remember back in chapter 4, we did b for the binomial, but now we're using n for the normal. And the mean for the z is 0 and the standard deviation is 1. And so I am looking at this shaded area. And so I'm going to share my screen. And I am looking at the normal curve here. You can see it on my screen here. and 0 and 1, but I want to know less than 1. So I'm going to delete my minimum is going to be at an infinity, and then my maximum is going to be a -1. So my picture in Desmos should match my picture on my paper. And that area is equal to 0.1587, rounded to 4 decimal places, always round appropriately, 0.1587. And that's written like this in my paper. You can say it's the area or probability. Example 2 says, what is the probability that z is less than 1.5? So I'm going to mark 0, and 1.5 is going to be somewhere over here. And so again, we're shading everything to the left because it's less than. And so that looks like this. And so I can go back to Desmos, and now my my max is still a negative infinity, and my minimum is a negative infinity. Let's just write that on the paper. And then my max is at 1.5. And then that likelihood is 0.9332. The next one, I'll show you my screen, my Desmos screen. So example 3 says, find the probability that z is bigger than 2.3. So 0 is our center, and 2 is going to be somewhere over here, 2.3. So 2.3, and greater than means we're shading to the right. And so my min this time is going to be 2.3, and my max is going to be a positive infinity. So I'm going to share my screen with you so you can see. So this time my min is 2.3, and my max, sometimes you have to hit delete there. So that likelihood is 0.0107. So not very likely. And that matches what we learned in the empirical rule. The empirical rule was bigger than 2 standard deviations was about 2.5%. I think it's actually 1.96 is actually about 2.5%. And so we're going to use this 1.96 quite a bit. Okay, so let's look at example 4. Okay, example 4 says, we learned earlier in the semester that an unusual observation is one that is more than 2 standard deviations above or below the mean. Use Desmos to find the sum of these probabilities. So let's look at a -2 and a +2. So that would be the probability of z being less than a -2, and then the probability of z being greater than a +2. Let's go back to here. So I'm going to do greater than a +2 is 0.0228. And then if I delete that and go less than a -2, we'll have the same 0.0228. And if we multiply that times 2, we get almost 5%. So 0.0456. And that's why we call it unusual, because it rounds to 0.05. So anything outside of here is considered unusual. We can also use Desmos to find an X value if we are given area. And So it says using Desmos to find the value of the variable given the mean and standard deviation. And the area. So let's look at example 5. It says find the z-score for the following situations for the standard normal curve. Round z-scores to 2 decimal places. So we are given an area. This is our alpha to the right, but we want the negative. So we want area to the left. So we know the area is 0.02 and we want to find the z-score that goes with that. So we are saying the probability that z is less than some z is equal to 0.02. And we know it's less than because it's negative. Here. So let's go to Desmos and we're going to use this command, inverse CDF, and then in parentheses, your normal distribution, comma, the area to the left, but it's really, we always enter the area to the left, even though we draw area to the right. So we're going to enter the area to the left. So let's go to Desmos. And I'm going to turn off my picture. The only bummer with the inverse CDF is it doesn't draw a picture. So our area to the left is 2. And it says that a negative 2.0537 is the z-score that goes with that. And we're going to round to 2 decimal places. So z must equal a negative 2.05. Now, if we wanted to check what this would look like, if it matches our picture, we could go down here and turn the graph back on and have it go from a negative infinity to a negative 2.05 and make sure it matches. So our area 0.02 does match our area here, and our z-score does match our z-score here. And then our picture matches as well. So a negative z of the alpha is on the left-hand side. It's the, the less than shading. And we have to remember that in Desmos, it's always the area to the left that we're entering. So let's look at another example. The next one says z of 0.08. So we want to find, this is going to be the positive z that goes with 0.08. So the probability that z is greater than some z is the area of 0.08. This is the area. So we're going to use our inverse inverse CDF. And so because we're doing area to the right, we're going to type the normal dist, and it's 0, 1, comma, 1 minus 0.08. Now, you could type in 0.92 if you want to go ahead and do the math. Or you could just tell it when it's the right-hand side, you just type in 1 minus the area on the right, and it will know. So I'll show you how this works in Desmos. So up here in my, I'm turning off my picture again. I'm going to type in 1 minus 0.08. And it gives me a positive z-score, and it should, because I am looking to the right-hand side of 0. So the z that matches this area is 1.41 or 1.405.